Hi students, welcome to my channel. In this video we are going to discuss rotations simple examples. Simple examples. Okay. So in previous videos I already mentioned what are the rotations we will apply in AVL trees. Okay, that already we have discussed. Now simple examples I will tell you. Okay. So now first rotation, single left rotation. Single left rotation. Single left rotation means suppose 10, 8. These two are there. Now I am inserting one new element like 3. Okay. So by inserting 3, so 3 is growing towards left side. Okay, after insertion, apply balance factors or find out balance factors. The balance factors here are leaf node it is 0. For 8 balance factor is plus 1. For a 10, so balance factor here it is plus 2 minus 0 equal to 2. So here the property is failed. Okay, so then you have to apply, tree is growing towards left side. So you have to apply the rotation, single left rotation. That means why it is called a single left rotation? Tree is growing towards left side. That's why here I mentioned single left. Of course, the same process may be explained with the single right rotation by other authors or other faculty members. So don't worry, the concept here it is. So that is, the concept is the same. Okay. So now the tree is growing towards left side mode. That's why here I am telling you single left rotation, LL rotation. So for here the property is failed. For this node this is left side. For this node this is left side. That's why here it is called as LL rotation also. Okay. So now apply single left rotation. Single left rotation is nothing but here 8. So tree will move like this. Then 10 will come down, 3 will come here. 3 is as it is. Okay. Take another example. For example, 40, 30. Now I have insert, for example, 20. Here it is 50. Now I have inserted some 10. Already, this is an AVL tree. This is an AVL tree. Now in this AVL tree I have performed insertion operation. 10 I have inserted. So after insertion, here we have to apply, you have to find out balance factors. So balance factor for 10 leaf node, here it is 0. For 20, here it is plus 1. For 30, so 2 minus 0, so plus 2. So for 40, plus 3. Now if it is the case, observe, in two places the property is failed. At node 30 and at node 40 the property is failed. Now in which node, at which node we have to apply the rotation first? So at bottom levels first we have to apply. That means this subtree you have to consider first. Okay. So now only at this 30 node you apply the rotations. Okay. So now, where again as usual tree is growing towards left side now. So single left rotation. Then the tree is 40. If you are rotating the tree like this, now here you will get 20. Here you will get 30. Here you will get 10, 40 and here you will get 50. Okay. So now, this is second example for single left rotation. Now coming to next rotation, single right rotation. Single right rotation. Students, so for the single left rotation, how you have applied in the same manner, here we will apply for right side. So now for example the tree is like this, 10, 20. That means this is an AVL tree. Now I am performing insertion operation. 30 I have inserted. Now, previously it is an AVL tree, but after inserting 30, check an AVL tree property. Here it is 0. For this, here 0 minus 1 minus 1. At node 10, it is minus 2. At this node, the property is failed and observe tree is growing towards the right side. So what I told, if tree is growing like this or like this, single rotations. Okay. So now tree is growing like this, a single right rotation. I already mentioned in the previous video. Please see that video if you have not seen. Okay. So now apply single right rotation. So then if you apply single right rotation, that means tree will move like this. So here you will get a 20, here you will get a 10, here you will get 30. Okay, now let us take another example like 10, 5, 20, 30. Okay, so now insert 35. I have inserted 35. Now, after inserting 35, check the balance factor property. Find out the balance factors. So, what balance factor for this? Balance factor for the nodes, here it is. Leaf node, here it is 0. For 5 it is 0. For 30, minus 1. For 20, minus 2. For 10, minus 3. What I told? So, here at 2 places the property is failed. Na? So, now here, now what I said? So, here at 2 places the property is failed, but at bottom level only we have to consider. Here only. That means if you balance this one now, automatically here the tree will be balanced. That's why you first check at bottom level only. So, 10, 5 as it is. 10, 5 as it is. Now, if you apply single right rotation, here you will get 30, here you will get 20, here you will get 35. Okay. After rotation, check whether it is an AVL or not. 0, 0, 0, 0, minus 1. So, how you are getting this minus 1? 1 minus 2 equal to minus 1. Okay. This is single right rotation. Next. Third one is double left right rotation. Double left right rotation means first apply single left rotation. Listen carefully. So double left right rotation means, so this is not a new rotation. Okay, just combine the single rotations, then you will get double rotation. That's it. Okay, so this is not a new rotation. Apply two single rotations, but how to apply is different. First, apply single left rotation at child node. That means a PTR's child. Okay, and then single right rotation at the node where the property is failed, at PTR. At PTR, single right rotation you have to apply. Then you will get the double left right rotation. Double left right rotation. So now, how you will get this rotation? Okay. So now, for example, the tree is like this. 10, 20. For example, here it is 15. Okay. Okay. So now if the tree is like this, now consider this one 10, for example, here it is, take it as 5, here it is like 8. Here you will get a double rotation. Okay, so now here also you will get, in this situation also, that means tree is growing like this now. Suppose 10, 20, suppose if this is the case. Okay, so here also you will get a double rotation. Now for this, which tree we will consider? Consider this one. So 10, 10, 20. This is an AVL tree. Now insert 15. Now observe balance factors. Here it is 0, here it is +1, and here it is -2. This is entire right subtree na, 0 -2. 0 -2 equal to -2. Okay, so now what I said, double rotation. So first tree is growing like this or like this, double rotation. See, tree is growing like this, like this. Then apply double rotation. So double rotation. So first apply single left rotation, and then apply single right rotation. Here the properties failed na. Here the properties failed. What I said, so at the child you have to apply single left. That's why here I marked single left here. So then 10, single left means here you will get 15. Here you will get a 15. Okay, so now here you will get 20. After that, single right rotation at the node PTR where the properties failed. Then the tree is 15, 10, 20. Don't calculate balance factors again here. After applying all 2 single rotations only, find out balance factors. Okay, see, here I told you first apply single left rotation and then apply single right rotation, which is nothing but your LR rotation. Or directly you can see, you can do like this. So if tree is like this, now make 15 as root node, 15. Okay, so as it is a binary search tree, 10 you will get on left side, 20 you will get on right side as it is greater. Like this also you can do. Okay, this is double left right rotation. Now fourth one is double right left rotation. So if you understand double left right rotation, so here you can apply this double right left rotation also. What is this double left right rotation? First apply single right rotation at child. Single right rotation at child. And then apply single left rotation at the node where the properties failed. Okay, that is nothing but that node we are assuming as a PTR. So at PTR apply single left rotation. So first what we have to apply? Single right rotation. For that resultant tree, apply single left rotation. So now consider this example 10, 20. This is an AVL tree. Now I have performed insertion operation, insertion of 18. Okay, then here find out balance factors. 0. For this here it is +1. For this here it is -2. Here the properties failed. Consider it as PTR. Okay, so for PTR. So now apply single right rotation at the child. That means like this. So 10, single right rotation. Single right rotation this already we discussed here. This is not the example. This here you will get actually double left right rotation. Here you are getting. Consider another example. This case you are not getting. Now consider this example, you will get the this case 10 5. So now 8 you have inserted. Okay, so now single right rotation and then single left rotation. So here the properties failed. 0 minus 1 plus 2. Okay, so now apply first single right rotation. So 10, here it is 8, here it is 5. For this resultant tree, apply, not for the original tree. For the resultant tree, apply single left rotation. So then the tree is 8, 10, 5, find out balance factors, which is an AVL tree. So these are the 4 rotations. Simple examples, explanation. Single left rotation, single right rotation, double left right rotation, then double right left rotation. Okay, in the next video, so we will discuss for the given numbers how to construct an AVL tree, and indeed which case we have to apply which rotation. That we will discuss in the next video. Hope you understand, students. If you understand, please share with your friends. Okay, so they can also learn this concept. Thank you, students. If you have not subscribed, please subscribe the channel. Have a great day. Bye.